are filled.
Is
Yes,
it
Chakrika.
because the oxygen will be in touch with the tungsten?
Exactly. That is the thing. When we break the glasses, now the tungsten will immediately fuse. Right now, it will break away. It will start to basically melt. Why? Because now it is exposed to oxygen. So now it will react with oxygen and it will basically burn, and hence it will melt. So the bulb will no longer light. Getting it, everyone?
Yes, sir.
Okay, now so that is the thing. Okay, now here's a video showing that what happens when too much of electric current passes through fuse. See, now the person is going to connect the wires to this fuse. Seen what happened? So this basically shows what? That excessive current was passing through the circuit here, right now?
Yes, sir.
Okay. And due to excessive current, a very high amount of heat was generated, due to which the fuse wire basically melted, right? Also, I did check your notes. Okay. I think Vaiga or Cheklik, I don't know who it was, but you have written somewhere like in place of the socket, you have written circuit. Okay, now. So those are two different things basically. It's a minor
Sir, I
mistake.
wrote socket.
You wrote socket now.
Yes, sir.
Okay. I don't know who it was then. But you have to write circuit over here. Okay, those are two different things. Okay. Also, you guys remember I did told you about to study about a scientist. I did told you to study about Orsted. Yeah,
When, sir?
I did. I did told you guys to study about Orsted. Oersted. This person. Did you guys studied about him? Yes. Anyone who has studied about him? None of you have studied about him. Who was Orsted?
Sir, I forgot the name. So
It was Hans Orsted. Hans Orsted. So he had done a very famous experiment. In this experiment, we basically did what? No, he proved that magnetic effect is produced when electric current passes through a wire. Okay. So before we move on to discussing about magnetic effect of electric current, first of all, you tell me, in the heating effect of electric current, do you guys have any questions? Any doubts?
What, sir?
In the heating effect of electric current, do you guys have any questions?
No, sir.
Everything is clear. So you guys tell me, the amount of heat generated in a wire or in a given electrical appliances will depend upon which factors. Let's start from
okay.
who will answer first? Vaiga?
Sir, wait, what was the
Yes, sir.
question?
Okay, the question was that the amount of heat that will be generated in an electric wire or basically in an appliance, electrical appliance, will depend upon which factors?
So, like, it depends on the material,
Material, good.
length,
Length,
and the thickness.
thickness. Length,
So there's also one more.
one more was there. Yes, you would like to answer that?
Can I, sir?
Yeah.
Sir, it's the magnitude of the wire. I mean,
Sir, is
Magnitude
it
of the
resistance?
resistance is there. Okay, resistance will be studied together with the type of material also. Right now, when we say the type of material there, it should be understood that we are basically talking about the resistance, right? Because different type of materials will be having different amount of resistance, right now. Okay, also in higher classes, when you would be going to class 9, there you will be studying about resistivity also. Okay, now see, resistivity and resistance are two different things. See, for example, let's say that in my hand, I am holding a copper wire. Let's say this is a copper wire. Okay. Let's say this is having this given length. All of you pay attention here. What if I were to bend it from here? Now the thickness increases. Right now, I have folded it. Now the thickness increases. So thereby, the amount of heat will be generated in it will be reduced. Yeah, because thickness is having inverse relation with the amount of heat generated. I think
Yes, sir.
I think two students were absent while we were not. Give me a minute. So I was saying that I think two of you were absent while we were talking about what factor influences the amount of heat generated in a given wire. I think those two students were absent. So let me revise that quickly. Like for example, you have this wire. I have this wire in my hand. So if I were to double it, so now thickness increases. Okay, now the thickness increases. Let's assume that I am having copper wire. There's no insulation over it. Okay. So now I have made it more thicker. So thereby lesser heat will be generated in it. Getting it now? Okay. What if I were to double it? If I were to double its length? Yes, you guys there or not?
Yes, sir.
Yeah.
Yeah, there.
So if I were to double its length, then also the amount of heat generated in the wire will not increase. Okay, now. So when you are
Okay.
increasing the length of the wire, then more heat is generated. Okay, when you are increasing the thickness of the wire, then lesser amount of heat is generated, right? But then I have, let's say, two same pieces of wire. Okay, let's say this is let's say this is nichrome. Let's say this is tungsten. The two will be generating different amount of heat. Why? Because also I am having these two wires, and these two are having same thickness, same length, yet they are producing different amount of heat. Why is it so? Because they are having different resistivity, and resistivity is a natural property of a given material. It does not changes. Huh? While resistance can be changed either by increasing the length of the given substance, either by increasing or decreasing its thickness, resistance will change. While
The resistivity,
resistivity,
resistivity change and resistivity is like naturally change.
no, it's not like that. Basically, the thing is like it's a natural property possessed by the given material. Resistivity is the natural property possessed by that material. Okay. While resistance is that I can increase or decrease the resistance being offered by a given material. Huh? If I were to increase its length, so thereby more heat will be generated. If I were to double it, and if I were to make it more thickened, so lesser heat will be generated.
Yes,
Why?
sir.
Because there I have changed the resistance of the given material. Okay. Also, you will study like there's a device. Okay. There's a device using which you can either increase or decrease the resistance. But the natural resistance that will be offered by the material, that you can't change. And that is called as resistivity over here. Huh? Okay, so just for now, just understand that resistance is basically uh, the the obstruction offered to the flow of electric current. That is resistance. And resistivity is also offering resistance to the flow of electric current. And yet these are two different terms, because the resistivity is the it's a natural property. It's a natural property. Okay. Well, resistance can be increased or decreased. Okay, hope you are getting this. I think even if you got a little bit of it, that is sufficient. Yeah. Did you guys got it or did you guys got confused? I think you
No,
guys got
sir. Got it.
got it now. Okay. Now, I already told you about Hans Ørsted. So Hans Ørsted was the scientist who basically did an experiment. Okay, and there he basically showed that when electric current passes through a wire, then a magnetic field is created around this wire. Okay, for that, in order to understand that thing, first of all, let me give you the crux of what are the things we are going to study in the magnetic effect of electric current. Okay, so first of all, this is also there. We will be talking about this device also. So, in the magnetic effect of electric current, we would understand first of all about magnets. Okay, the two poles of the magnet, right? And then we have got natural magnets, and then we have artificial magnets also. All right now, and then we would be talking about uses of magnet, right? These things are there. Most important of this is the types of magnets. Okay, in artificial magnet you will get to see that you can basically turn a piece of soft iron or hard iron into a magnet. Okay, how? We will be understanding that also. Okay, there you will be studying about electromagnets. Okay, so those things we'll be studying under this. And most important is the Ørsted experiment here.
So in magnets, will we study in about like not in the sense about, but like um about permanent magnets and temporary magnets?
Mhm. That we are not going to study in detail here. Okay, now in just
Oh,
one
okay.
line we'll be covering that because the basic goal is to cover magnetic effect generated due to electric current. Okay. Also, one more thing we would be talking about here about the
Okay.
magnetic field also. Magnetic field and what are magnetic field lines? Magnetic field lines. Yeah, Tassin, how are you?
Sir, fine. How are you?
Yeah, I'm also good. Okay, first of all of you have a look at this of a 5-minute video. Okay, now. Hmm. Tell me if the volume is too much, okay?
Introduction. When your friends come to visit you, they ring the doorbell. You hear the ringing bell and know someone is at the door. The electric bell produces sound using magnetic effect of electric current. Let us discuss the magnetic effect phenomenon of electric current in this module. Objectives. At the end of this lesson, you'll be able to explain the magnetic effect of electric current, define electromagnet, describe the working of electric bell. When an electric current is passed through a wire, it behaves like a magnet. Let us perform a simple experiment to understand it. Take a thin insulated copper wire and fix it in the north-south direction. Place a compass needle, which is a tiny magnet, under the wire. Connect the two ends of the wire to a battery. When no current is flowing in the wire, the magnetic needle is parallel to the wire and points in the usual north-south direction. The needle gets deflected from its north-south position when current is passed through the wire. When electric current is switched off, needle returns to its original position. This shows that an electric current produces a magnetic field around it. Let's perform a simple activity to show the magnetic effect of current. Take a long piece of flexible wire and wrap it around an iron nail. This forms an electromagnet. Connect the free ends of the wire to the terminal.
Okay. Remember a few moments ago I did told you about electromagnet. We would be talking about electromagnets also, right? And I did told you that you can have a piece of iron, okay, and then it can be converted into a magnet. Okay. So that is the thing which is being explained in this video right now. Okay. Also, here, basically what basically happened here now. See, this is the north and the south pole of the needle. And this needle, you can see it in the magnetic compass. And in fact, this is the same experiment which was being performed by Hans Ørsted. All right. So when he did the same experiment, he did saw that now this was getting deflected towards the wire. Also, you can notice here that the wire and the magnetic compass here, compass needle here, both of them are parallel to each other. As soon as this switch was turned on, basically it deflected towards this, right? That we'll be studying later on, like why it got deflected towards this side. Okay, the basic the basic thing here is that you guys already know, like the unlike poles of the magnet, north and south will attract each other, and the south and north, same thing, they will be attracted towards each other. So hence here a magnetic field is generated here, and this one possesses the south pole, this one possesses the north pole. Getting it now? So that is the thing. Okay, let's proceed further.
Flexible wire and wrap it around an iron nail. This forms an electromagnet. Connect the free ends of the wire to the terminals of a cell through a switch. Now, place some pins near the end of the nail and switch on the current. We see that the pins cling to the tip of the nail. When the current is switched off, the pins no longer are attracted to the nail. The coil in the above activity behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. Thus, an electromagnet works on the magnetic effect of electric current. You must have observed cranes lifting heavy iron scraps in scrapyard. These lifts make use of electromagnets for lifting and transporting large masses of iron scrap, girders, plates, etc. It is also used to separate magnetic material from the junk. The main advantage of electromagnets over the normal magnets is that they can easily start and stop, and the strength of the magnetic field can be effectively controlled. Electromagnets is also used for magnetic resonance imaging, getting a detailed image of the inside of the body to diagnose a number of diseases. A variety of electrical devices such as electric bell, microphone, loudspeaker, etc. make use of electromagnet.
Okay, so in the animation, did you guys got anything from it? Understood what was being explained here? Yes. Hello. You guys got it or not?
So,
Okay, so basically, Hans Ørsted in the year 1820, he did an experiment. He did the similar thing. He did the similar thing where he had a circuit like this. And when the switch was turned on, the needle was getting deflected from its usual path towards the wire here.
Yes,
Why?
sir.
Why? Because we get to see that when current flows through a given wire, so thereby it generates a magnetic field, right? So understand this thing also. One more thing, you might have seen such videos where you would be having a piece of paper, and on that you would place a bar magnet having north and south pole as follows, like this. And if you were to spread some iron fillings over it, what are iron fillings? Iron fillings are minute particles of iron, basically iron powder. So you spread some iron fillings over it. So thereby they will organize themselves around the poles of the magnet. Okay, they will be attracted towards the poles of the magnet. So thereby now they will be attached nearby to the poles of the magnet like this. Okay, now in this fashion they will arrange themselves in this fashion like this. You might have noticed here that in this given magnet, maximum amount of magnetic iron fillings are getting attracted towards the poles of the magnet. Hence, the magnetic field must be very strong here, right? That is one thing. Second thing to be noted here is that this is the north and the south pole. So you might you can see that we can draw some imaginary lines here. See from where we can trace a pathway, we can trace the path in which the iron fillings have arranged themselves. So we can trace a path here like this. Getting it? What I'm doing here? We can trace a path here. And these lines are called as, and since you know, like a magnet will have a magnetic field. Magnetic field is what? If you place any magnetic material near to the magnetic field of a magnet, then it will be attracted by the magnet. But if I were to place an object here, let's say, then it will not be attracted. You have to place it inside the magnetic field so that it gets attracted towards the magnet. Second thing here, you see these lines, you would say that these are called as magnetic field lines. These are called as magnetic field lines. And here it appears as if the magnetic field lines are coming out of the North Pole and then entering the South Pole. It will appear like this. All right now. Getting it so far or not? Yeah.
Yes, sir, getting it.
Okay.
Yes.
Yes, sir, getting it.
So that is
Okay.
basically what happens. Same thing is seen here in the case of this wire also. It will also develop magnetic fields around it like this. And due to the generation of that, and also magnetic field also will be having north and south pole right now.
Sir,
Yes,
I have a electric circuit set.
you have it. Oh, that's
Yes.
good. That's good. Okay, do one thing. After the class, make a video of it and send it on the group. I would like to see it. Okay, now.
Yes, sir.
Okay. So that is basically what is happening, that when electric current is flowing through a current carrying conductor, it will be producing a magnetic field around it. And this can be seen with the help of this magnetic compass, that it will start deflecting towards the wire. All right now. Hmm. So this was the same experiment done by the Orsted. So do remember that also. So his method was his method basically was to study about the magnetic field created.
Okay, sir.
Also,
Sir, I have a doubt.
yes,
Sir, is it ORSTED or is it OERSTED?
it is OERSTED. Okay, OERSTED. Okay,
Okay, sir.
okay. I think the spelling is correct. It is OERSTED. I think. Yeah, that is the spelling.
Yes,
Orsted
sir.
experiment. Right now. Also talking about like magnets, you guys know like magnets are natural and then artificial magnets are also there. And the natural
Yes.
magnets are basically coming from the mineral called as magnetite. Right now, magnetite. So magnetite is the natural mineral from which there is a very famous story. I think in some classes I might have told about this. There was a old shepherd, right now. So what basically happened? One day he was walking through somewhere and his iron stick, okay, now
Yeah, I
it
know
got
this
stuck
story.
to. You know this?
Same. I also know the story.
Okay, okay. Tell us what is the story.
Well, like in the
Mm.
sixth standard, my teacher said it. So I think I remember, but I know the story.
Uh, Basically, the thing was now what happened that he had a stick, okay, and the base of the stick had a
I think it was getting
iron cover over it.
attracted. Uh,
Mm.
To a
uh,
stone.
the, yeah.
Exactly.
So
It got
and that
stuck.
the farmer, it
Mhm.
was from Greece, I think so, right? It was from the
Exactly.
Greece with
Yeah, yeah.
it the G, and then something was like very GG. And like his name is from starting from G. His everything is starting from G. I was like, what the hell? When my mom said it.
Uh-huh. So basically, he belonged to Greece here right now. So look here, there are several things which are derived. You might have seen such and such word is derived from Greek or from Latin, because you get to see that the discovery of that thing took place in Greece or either in Italy or either in Latin, right now. So if something is discovered, let's say here in India, so it would be having an Indian name, right? So that thing was discovered there in Greece, so it would be having a Greek name. So that is the thing. So the thing was that his iron stick basically got stuck to a piece of rock. So at that time, people didn't know that what this thing was. Later on, several years later, people discovered that this was basically magnetite iron, magnetite mineral.
Sir, this wasn't an artificial magnet, it was a natural magnet.
Exactly, this was the natural magnet. Okay, now. So later on, people started studying it, and then people saw that some magnetic materials like iron, cobalt, and nickel were getting attracted
Nickel.
towards this. Yes. Yeah. Anyone wants to say something? So these magnetic materials were getting attracted towards it. So hence, in this manner, basically, magnet was discovered. So that is a discovery. That is a natural magnet. You might also
So
had
like
heard about.
ask this. The
Yes.
like is like the sand. Does it have like a type of magnetic compound in it? The
The
sand.
sand. Again, repeat that. I didn't heard the full question.
Like this sand has a magnetic compound because like in museum I went to it and I saw the
Mhm.
experiment in which like the magnet like it separates sand from the water. I didn't actually understand the concept of it.
Magnet separates sand from water. Look, sand is basically what? Sand is basically compounds of silica. Okay, now silica oxide is there. Sand is basically made up of silica oxide. Okay. So silica, it might be a different thing, I believe. It might be either having cobalts or nickels or some pieces of iron, some iron fillings or iron powders might be there. Okay. So it might be like that because these are the only things which are known to be magnetic in nature. Okay, these are the magnetic substances. Those substances gets attracted towards a magnet. Namely, it's iron, cobalt, or nickel. It might be having some compounds of cobalt, nickel, or iron. So thereby it might be getting attracted. Okay, now. So hope that answers the question. So magnetism was first discovered by the person who lived in Magnesia. Magnesia was a place in Greece. Is a place in
And
Greece.
his name was Magnus.
Magnus, exactly. Right. So from his name, the magnet was named. The name magnet came. All right. Now moving ahead, talking about artificial magnets. Artificial magnets are what? Huh? There are different ways in magnets can be created. Also, moments ago, I was telling about lodestone. So lodestone was what? It is also a naturally occurring magnet. Okay, no. So when magnetic compass was not discovered, people were using lodestone for navigation purposes. Okay, now do remember that thing. All right, now. Okay. So talking about the artificial magnets, you have the electromagnet. Electromagnet is what? Basically, the thing is now, you know that through a piece of wire, electric when electric current will flow, magnetic field be generated, right? But what if I were to make coil of that wire, okay, and then pass an iron object inside it? So now the amount of magnetic field produced will be more. Getting it now, right? So when you have coils of wire wrapped around a piece of iron object, iron basically, then also magnetic field is produced, right? And that is called as electromagnet. So let's to understand like what is a electromagnet as well. So here you can see that this is a piece of iron. This this is basically an iron bar, and you have connected basically wire to this battery, and the wire is basically wrapped in coils around this iron bar. And as soon as the current starts flowing thereby, you can see the magnetic lines are generated here, okay? And you can see that magnetic field lines are also created over here, right? Now you would see that pieces magnetic objects like the iron objects will be getting attracted towards it, and as soon as the current supply is stopped, it will stop behaving as a piece of magnet. So every magnetic material has a magnetic field up to which the inference of its magnetism can be experienced. And a magnet whose magnetic field is generated with the help of electric current will be called as electromagnet simply. And it is again created due to the magnetic effect of the electric current. Okay. In higher classes, you would be studying about these magnetic field lines. Also here, the direction given here in this diagram is actually wrong. Okay, now the magnetic field lines, their direction is like this. It starts from North Pole and then enters the South Pole, right? Getting this thing or not? Most probably in class 9, you will be studying about in detail.
Can you repeat what did you just say?
I just said here, like the direction of the magnetic field lines are like this. It starts from north and then ends into the south pole of the magnet. Okay, now? Same thing for this one also. Here as well.
Okay, sir.
Actually, I just noticed that the arrow was pointing in the wrong direction. Okay. Also, what does the magnetic field lines denote here? For example, if I were to have two magnets here, okay, say that this is the magnetic field lines of this magnet, like this, and then let's say this is the magnetic field line of the another magnet, which is like this. What difference you guys can notice here? What would be the difference between the two magnets here? Yes.
Can you repeat again?
My question is that what would be the difference? What difference do you notice in this figure and this figure? Apart from that, there are more magnetic field lines in this one.
Sir, in this one, the first one, it doesn't have a lot of magnetic poles attracting. The second one has a lot of magnetic poles attracting.
Yes, anyone else?
The arrows are missing in this first one.
Okay, let me draw it then. Now,
Yes, sir.
so basically, as Tehsin was answering here, basically you would see that the strength of the magnetic field is differing. Obviously, the strength of the magnetic field of the second magnet is more, right? Since there are more magnetic field lines here. Also, the field of also the influence of magnetic field will be more, right now. So that is the thing about the magnetic field is basically shown with the help of the magnetic field lines, right? And also you could see that the direction and the strength of the magnetic field here are represented by the magnetic field lines, right? The direction here you can see these are exiting from the north and then entering the south pole of the magnet. Is there any question so far in this one? Also, you guys tell me, like, are the magnetic field lines intersecting anywhere? Are they crossing each other like this? Are they intersecting? Yeah. Do
So
we
are
see
you
like
talking
they are?
about the pieces?
Yes, I'm talking about
The pieces.
both of them. Both of them.
So no, I don't think.
No, right now. So yes. Hello. You saying something?
Nothing.
Okay. So that is the thing here. All right now. So no two magnetic field lines will be intersecting each other at any given point. Okay. So that is the thing. Also, I did told you that if you were to put some iron fillings over a piece of bar magnet, it will arrange in this fashion, right now. And when you draw a line, when you trace its path, that then you will be getting the then you will be able to draw the magnetic field lines. Orsted experiment. I hope it was clear to everyone. Yes. Now, you guys tell me that
Can you go to the previous slide once?
is it this one?
Yes, sir. You can continue.
Okay. Now, see one more thing over here. Hmm. Now, here you can see one more thing, that if you were to look at the magnetic needle, magnetic compass needle here, the direction of the deflection here is different in the two figures. Huh? Why is it so? Because if the direction of the flow of current is reverse, you can see here, what is the direction of the flow of current here? Starting from the positive terminal, ending towards the negative terminal. It is flowing in this direction. Everyone pay attention here. Look at the diagram. It is flowing in this direction, the current is flowing in this direction, right?
Yes, sir.
And in the next figure, I see that now the current is flowing in this direction.
Yes,
I
sir.
have
Because the current flows wherever the positive side of the battery is.
exactly, it flows from the positive terminal into the and then enters the negative terminal of the battery. That is a general thing. Okay, but then look at the direction here. Here in this circuit, it is flowing in this direction, and here it is flowing in this direction, towards this direction, and here it is flowing towards this direction. So we have reverse the direction of current flow here now, right? So then we
Yes.
also notice one more thing, that as I have reversed the direction of current flow, hence the deflection is also reversed here. Here, see, it was moving in this manner. See the dotted lines. Look at the dotted lines. That shows the deflected position of the magnetic needle here, and here this shows the deflected position of the magnetic needle. So
Okay, sir.
we can see that if the current is the direction of the current is change, hence deflection also changes. So let me just conclude what are the things we did studied in this. So when electric current flows through a current carrying conductor, it produces a magnetic field. Okay. Second thing is that the direction of deflection of magnetic compass needle changes if we change the direction of flow of current. The direction of flow of current. And this was the same activity being performed by Hans Oersted. experiment. Okay, if anyone wants to note this down, please do note it down. Okay, shall I move ahead? Taking a screenshot or written it?
Can you just wait 1 minute?
Okay, okay. Also, you guys know that Earth is also having a magnetic field now. Earth also behaves as a giant piece of bar magnet. Yeah. So you guys tell me one more thing. You know that this is the north pole of the Earth, this is the south pole of the Earth. Where does the north and south pole of the magnet lie? Where does the south and north pole of Earth's magnet lies?
So can you say the question again?
My question is that here you have the north and south pole of Earth. These are the geographic north and south pole, right? Let me write this. This is the geographic north and south pole. Can you tell me where will be the north and south pole of the magnet lie here? Because you know Earth also behaves as a giant piece of bar magnet. To tell me this thing. So basically the thing here is that, shall I answer or you guys want to answer this?
So is this sideways?
No, it's not sideways. It is aligned as the axis is aligned here. It is aligned alongside the axis. But the thing is that the north pole of the Earth's magnet is towards the geographic south pole, and the south pole of the Earth's magnet is towards the geographic north pole. So it is just opposite. Okay, now getting this thing now or not? So you can note this thing down also somewhere. Yeah, Sundas?
Yes, sir. I'm
Can you repeat?
I just said here now. Our Earth also behaves as a giant piece of bar magnet. Magnet also comes in different shapes now. Horseshoe magnets are there, bar magnets are there, bar shaped magnet, right? You have ring shaped magnet, etc., oval shaped magnet. So this is a bar shaped magnet. Our Earth is also behaving like a giant piece of bar magnet. But the thing is that the south pole of the magnet of Earth is lying towards the geographic north pole, and the north pole of the magnet is lying towards the geographic south pole of the Earth. Is that clear now? Hmm. Is that clear to everyone?
Yes, sir.
Yes.
Okay. Also, one more thing has to be noted here. What if I were to increase the amount of cells here? If I were to connect some more cells in this, so I am basically increasing the current. So now the deflection will be more. All right now. So shall I erase this thing over here? This diagram, this one. Let me point it.
Yes.
Yes, sir.
The Earth diagram. Okay, because I need some space over here. If someone wants to take a screenshot of it, take it. Okay, I'm erasing it. So second thing is that when we increase the current flow, then more deflection is seen. More deflection is seen. Okay, note this thing towns, and then we will be now studying about what is the concept of how does an electromagnet works and what is electromagnetism. Yeah, do let me know once you guys are done.
Done.
Done, everyone? Okay, I'm moving ahead now. Just now we did talked about this electromagnet thing. Okay, and then the question is that what is electromagnetism then? Okay, while making notes, first you will write about the electromagnet, then you will write about electromagnetism. Okay, now the order of the slides is not proper, but first you will write about electromagnet, then you will write about electromagnetism.
So, but I wrote it way before.
Okay, you have written it already. Okay, no issue. then you can write it in the corner, like just make a bracket and then write it. Okay. So basically electromagnetism is what? It is basically the phenomena of producing or inducing a magnetic field because of the flow of electric current. Huh? You have a piece of, let's say, iron bar here, and you connect wire to it, and then you connect it to a piece of battery, right? So after you switch it on now, then we get to see that it also produces magnetic field like this, like this. And these are what do we call this as? Yes, what do we call this as?
Uh,
We call this
Magnetic.
magnetic
magnetic field,
field of lines, magnetic field lines.
magnetic field lines, right? Also the magnetic field lines, they starts from the north pole like this, and they appear to be entering the south pole. So this is the south pole, this is the north pole. Okay now. So that is the battery which has been turned on. So basically the thing is that here the magnetic field is produced. So basically the phenomena of producing or inducing a magnetic field due to the passage of electric current, that is simply called as electromagnetism. And electromagnet is the artificial magnet basically. Okay. So let me write this. The phenomena of producing or inducing a magnetic field. You guys know you guys can turn a piece of iron nail into a temporary magnet. I will be telling you that also without rolling a piece of wire over it. Even then you can
We can
turn
just
a
rub it
piece
in
of,
a natural.
exactly, you can rub it basically on a magnet. Okay, now there's one more thing we can do. Let me
A
first
natural
complete this. Yes.
So what is after off?
Of producing or inducing a magnetic field
Okay.
due to the passage of electric current is called as electromagnetism. Yeah. So as Sundar was saying now, like we know that due to the phenomena of electromagnetism, uh, uh, electromagnets are produced, which are the artificial magnets. What if you were to have a piece of iron nail over here and you are required to turn it into a magnet, just to induce some magnetic property in it, for just a temporary time. So as Sundar said, you can rub it over a piece of magnet. That is one thing we can do. Good. Second thing is that what you can do now, you would take a piece of iron nail, okay, and then you would take a piece of bar magnet, and then you will rotate it around like this. In this manner, you will bring this piece of magnet close to it and then took it away. So like this, you would repeat this process for several times. After sometimes you would see that this piece of iron nail would gain some magnetic property, right? So when you will study about it now, thereby you will get to see that basically what happens now due to the due to this particular movement of this bar magnet alongside this iron nail, what happens, the arrangement of electrons, right? The arrangement of electrons inside this iron nail is somewhat disturbed. So hence due to that, for a temporary period of time, it develops magnet-like property right now. So that thing also, I think you guys are not required to study that thing, but you can know, like in this manner also, a piece of iron nail can gain magnetic property for a temporary period of time. Getting this thing or not?
Yes.
Okay. Now the question is, where do we use the electromagnets? So basically, like you have several appliances. For example, in the electric bell, there the concept of electromagnetism is used. Okay, so we will be understanding about functioning of that also, how basically an electric bell works, right? Then you will see that it will be used in toys also. You would see that in the loudspeakers also, a piece of magnet is used right now, and there basically electromagnets are used. Also, my question is that you would have seen like cranes, they lift high, they would be lifting heavy pieces of iron crabs. But in place of electromagnets, why I am not using the natural magnets? What is the reason?
The what?
Why electromagnets are preferred for use in cranes that lifts the iron scraps? Why electromagnet is preferred to use? Why not the why we aren't using the natural magnets? Yes. Are you guys getting my question or not?
Sir, can you repeat again? I'm sorry.
Sure, sure. My question is that why we are not using electromagnets in cranes? Like you have some cranes now, yeah, that have got electromagnets in them. You might have seen like I'm just drawing the hand of a of a crane. Let's say this is having a giant piece of electromagnet, and then iron scraps would get attracted to it towards it. So why is it so that I would be using an electromagnet here, and why I won't be using a natural magnet? Why we prefer to use electromagnets in cranes that are used for lifting heavy pieces of iron scraps? In place of that, why we won't be using? Hmm, they completed.
Because they are made for. They are electromagnets are made for like lifting heavy objects.
Basically, the thing is that
Sir,
Sir, electromagnets are used to pick up big iron pieces.
hmm,
So it is like used for picking up iron pieces. But in cranes, I don't know, sir.
sir,
like
can
it's
I
a
say?
having a same structure like that. Yeah, Chakrika, continue.
Sir, is it because the electromagnets can hold on to the materials when the electric current is passed? Like they
Also,
have the
please,
efficiency to hold the iron loads?
strength would be the proper word to use here, right? The magnetic field strength is more, right now, as compared to natural magnet. Electromagnets are having more strength. They are having more electromagnetic, more magnetic strength. That's why we would be preferring to use that. Okay, now. So that is the thing. Also, you would see that if I want to, if I want, I can. Electromagnets can be turned into a. You can basically when you will be turning the switch off now, it will no longer be a magnet, right? The magnetic property will be loosed as soon as you turn the light off, as soon as you turn the switch off,
Oh,
right?
yes, sir.
While in the case of natural magnet, there's no such thing, right? It won't be losing its a magnetic property. Also, you know that natural magnets are weaker. Weaker in what sense? They are brittle. They are brittle. Brittle meaning that they will break into pieces. If they were to drop from a height, they will break into pieces. While electromagnets are made from iron, hence they will not be breaking. So these are some general things. Okay.
So, sir, normal magnets are not used because they don't have the capacity to hold on to bigger or more heavier things.
Exactly, because they are not having that much of of magnetic strength.
Okay, sir.
And then they are brittle in nature, meaning that they would break into pieces if dropped from a height. All right. So these are
Okay,
the
sir.
things.
So, like I heard, like we can weak the magnet by heating it. Is that true?
We can do what?
We can weaken the magnet by
Uh-huh.
heating is
Exactly, that is true. You can A magnet will lose its property if it were to be heated. Huh? Also, if two magnets, okay, were to be placed in such a manner that the like poles are placed alongside, in that case also the magnets will be losing its magnetic property over time. What I mean to say that if two magnets were to be kept in a box like this, they were to kept like this such that this is north pole, this is north pole, so they will be repelling each other right now. So over the period of time their magnetic strength will be weakened, right? Also dropping from a height will also result in loss of magnetic property. So in class 6 you might have studied about all these things right now. So application of electromagnetics, these are used in some domestic appliances, for example, in the electric bells. These are used in toys. These are used in loudspeakers, right? They are used in the cranes to separate magnetic materials from junk and to lift the heavy objects as well. Also, suppose, yes,
they are using motors as well.
exactly. In the motors also they are used. Very good, right? In the generators also it is used, right? Whether in the motors or in the generators it is used. Also, if there were to be some magnetic material that has fallen in someone's eyes, so with the help of a magnetic magnet, it can be removed from the eye as well, right? Okay, moving ahead, let's understand the functioning of this electric bell. Do we have time left for this or not? Okay, let me just know. In short, let me just explain this. We will be continuing from here in the next class. Okay, so basically, in the electric bell, you have a battery, you have a switch, and then you have this spring over here, right? And then this is the electromagnet, and the poles are as follows: north pole and the south pole. Okay, and then you have got a gong here, that is basically a dome shaped structure, and then you have this hammer, and then this hammer is attached here to this spring. So basically what happens, see, as soon as the switch is turned on, so when the switch is turned on, the circuit is complete here, right? Just listen to me, I will be writing the things down in the next class. So due to the flow of electric current, now uh, this here magnetism will be generated. This will generate this will generate magnetic field right now. So due to the generation of magnetic field, what will happen, this hammer will now touch the gong right now. So this will touch the gong and hence sound will be produced right now. As soon as this will be touching it, now you would see that now here the circuit is will be broken. This will detach from here. Now the circuit is broken, right? The circuit is broken. Now this will fall back. This hammer will now fall back,